Hello and welcome to this revision session for Paper 1 in AQA A-Level Physics. So in today's revision session we're going to be looking at multiple choice questions and looking at how to answer examination questions on AQA A-Level Physics Paper 1. So if we're being successful and we learned in today's lesson, we should be able to answer A-Level Physics examination style questions, in particular multiple choice examinations questions. Assess our understanding on A-Level Physics and understand what topics and questions we need to improve upon for AQA A-Level Physics. So how should you prepare for this revision session? Well, when completing your work in this revision session, divide your piece of paper into two sections. Make the section on the left hand side larger than the right hand side, and in this left hand side section write down your working out and answers to the question in the revision session. Make sure when you do this you show your full working out even though it's not required for multiple choice questions. Then in the right hand side write down any bits of information which you find useful or any hints and tips on answering questions from the revision session. And at the end of the revision session please write up these notes into a revision sheet for you to use independently. So how should you be revising AQA A-Level Physics? Well, the first thing is you should be learning the key facts. So use revision guides, class workbooks, student prep notes, the textbook to learn the key ideas of the course. Then secondly, retrieve your knowledge by testing yourself. Use things such as Caboodle, Seneca, knowledge checkers to quickly test your own knowledge before finally practicing exam style questions. So using exam prep books, homework books, supervised study books, additional workbooks to answer examination questions and mark your own work. So the three steps of learning the key facts, testing yourself and then practicing exam style questions are how you should be revising AQA A-Level Physics. So let's now have a look at some multiple choice questions which will come up on Physics Paper 1. So the first topic we'll look at is particles and radiation. So, which row identifies an isotope of P and the nuclear number of this isotope of P? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question our answer is B. Why is that? Because an isotope has the same number of protons but a different number of neutrons. So therefore this has to be Q. Now the nucleon number is the number of protons plus the number of neutrons, so therefore it'll be X plus Y plus 1, so our answer is B. The next question says 23692 uranium undergoes a series of decays to produce 20482 Pb. How many alpha decays are involved in this decay series? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer for this one is A, because in one alpha decay the proton number decreases by 2, and so in this question you can see it goes from 92 to 82, so the proton number is decreasing by 10, indicating that 5 decays have taken place. The answer is A. The next question says, the diagram shows the energy levels in an atom drawn to scale. Now, a transition from E4 to E2 causes the emission of a photon of green light. So which transition could cause the emission of a photon of red light? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, you know that red light has a longer wavelength than green light, so therefore it'll require a smaller amount of energy, because you know E is equal to hc over lambda, so therefore we need a smaller energy difference which will be E3 to E2, so our answer is C. The next question says, mercury atoms in a fluorescent tube emit photons when they de-excite. Some of the photons cause fluorescence in the inner coating of the tube. What is the region of the electromagnetic spectrum to which these photons belong? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, our answer here is A. Now this is rote learning because when mercury atoms de-excite, they release ultraviolet photons due to their differences in the energy level values. So the answer has to be A. The next question here shows an atom in the inner coating of a fluorescent tube absorbs a photon of ultraviolet radiation. This causes the excitation of the atom from its ground state, and a photon of the visible light is then emitted. So which energy level diagram represents this process? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer is D, because the ultraviolet photon has caused an excitation. Now the UV photons have a larger energy than visible light, so will cause a larger energy level jump. Now when the electrons de-excite, the electrons drops down levels, but this will not be of a large of a jump as the jump up, because the photon releases in the visible spectrum, which has a lower energy content than the ultraviolet photons. The only one where this is possible is D. Right, the next question says 23290 thorium is an unstable nuclide in a radioactive decay series. It decays by emitting an alpha particle. The next two nuclides in the series emit beta minus particles. What nuclide is formed after these three decays have taken place? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, our answer is D, because the alpha decay decreases the top number by 4, so 232 minus 4 is 228, and the bottom number by 2, so 90 minus 2 equals 88. Now the beta minus decay keeps the top number the same, so 228, and then the bottom number increases by 1. Now this occurs twice, so the bottom number therefore can becomes 88 plus 2, which is equal to 90. So therefore our top number is 228 and our bottom number is 90, so the answer is D. The next question says, which line does not give the correct exchange particle for the process? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer is A, because the electrostatic repulsion occurs due to the electromagnetic force, which has an exchange particle of a photon. The strong interaction occurs between particles due to pions, and therefore the beta decay occurs due to the weak interaction, which has an exchange particle of a W boson. So therefore the incorrect answer is A, where it's the gravitational attraction and the exchange particle is the graviton, not the W boson. Right, let's now have a look at some questions regarding waves. So, first question says, which of the following waves cannot be polarized? So pause the video now, then unpause the video when you want to go through your answer. Right, the answer here is B, because ultrasonic waves are longitudinal waves, the other three are transverse waves. Now only transverse waves can be polarized, so therefore longitudinal waves cannot, so our answer is B. The next question says, which row correctly describes the wave properties that can be demonstrated by light waves and sound waves? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? So the answer here is B. Why is that? Because firstly, all waves can form a stationary wave, but only transverse waves can be polarized. Now, light is a transverse wave, so it can be polarized. Sound waves are longitudinal waves, which cannot be polarized. So therefore, our answer is B. Now the next question says, the diagram shows a stationary wave formed on a string of length 0.60 meters. 2 points on the string are separated by a horizontal distance of 0.30 meters. What is the possible phase difference between these 2 points? So pause the video now, then unpause the video when you want to go through your answer. Right, how do you answer this question? Well, we can see on this particular diagram that if we have one wavelength, okay, to be 0.60 meters here, we can see that 0.30 meters is going to therefore be half a wavelength. So therefore, if one wavelength is 2 pi radians, therefore half a wavelength is going to be pi radians. So our answer is therefore going to be D. The next question says, the frequency of the first harmonic on a standing wave on a wire is F. The length of the wave and the tension in the wire are both doubled. So what is the frequency of the first harmonic as a result? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is A, because we know from the equations that F is equal to 1 over 2 times by L multiplied by the square root of T over mu. Now because we're using the same wire, mu is a constant, so therefore if L and T are doubled, well then F will increase by a factor of 1 over the square root of 2, so therefore our answer is A. The next question says, the frequency of the first harmonic of a wire fixed to both ends is 300 Hz. The tension in the wire is now doubled, so what is the frequency of the first harmonic after this change? So pause the video now, then unpause the video when you want to go through your answer. Right, so the first one, as we mentioned before, f is equal to 1 over 2l times by the square root of t over mu. Now, mu and l are constant in this question because we've got the same wire and we've got the same length of wire. So therefore, we can see that f is proportional to the square root of t. So therefore, if t is doubled, well then f will have increased by a factor of square root 2. So 300 times by square root 2 is 424, so it works out to be C. The next question says, when a parallel beam of monochromatic light is directed at two narrow slits S1 and S2, interference fringes are observed on the screen. Which line in the table gives the changes that will increase the spacing of the fringes? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know for this particular example, the equation for the double slit experiment is W is equal to lambda D over S. So this tells us that if S decreases, W will increase. It tells us that if lambda increases, W will increase. And if D increases, W increases. So therefore, the answer is B. The next question says, two coherent sources generate sound waves of wavelength 0.40 meters. The waves leave the source in phase. A detector some distance from the sources receives the sound waves. The path difference between the detector and the sources is 0.90 meters. So what is the phase difference between the waves arriving at a detector? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is going to be C, because if the path difference is 0.90 meters, then there's a difference of 2 1/4 wavelengths, because one wavelength is 0.40 meters. So therefore, if it's a quarter wavelength that we're out by, it gives us a phase difference of 90 degrees, because remember, when it goes round 2 1/4, we'll just give a difference of a quarter, because it's gone back to the start after 2 and then moved a quarter. So as the two lasers will cancel through and the quarter wavelength is 90 degrees, our answer is C. The next question says, a diffraction grating is illuminated normally with light of wavelength 6.5 times 10 to the minus 7 meters. When a screen is 1.5 meters from the grating, the distance between 0 and the first order maxima on the screen is 0.30 meters. What is the number of lines per millimeter of the diffraction grating? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the correct answer is going to be C, because we know n lambda equals d sine theta. And then we can look at our right angle triangle that we've got and say that tan theta is opposite over adjacent. So it's going to be opposite, which is 0.3, divided by the adjacent, which is 1.5. So that gives us a theta of 11.3 degrees. So therefore, we can pop that into the equation and we get d out to be 3.3 times 10 to the minus 6. Now we know the number of lines is 1 over d. So therefore, we get 301717 per meter, which if we wanted it into per millimeter, we divide that by 1,000. So we get 301.7 per millimeter, which is 3 times 10 to the 2. The next question says, white light passes through a single narrow slit and illuminates the screen. What will be observed on the screen? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, when white light is passed through a diffraction grating or through a single slit, the central maxima will always be white and the other bright fringes are the colours of the spectrum, with the blue light being closest to the centre and therefore red light being the furthest away from the centre in each of the fringes. So therefore, our answer is C. The next question says, a diffraction pattern is formed by passing monochromatic light through a single slit. If the width of a single slit is reduced, which of the following is true? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, from our equations for diffraction, we know that when the width of a slit reduces, therefore the width of the central maxima will increase, but because the width of the maxima has increased, yet the amount of light is in fact going to be the same, it tells us that the intensity of that maxima will be decreased. So therefore, the only possible answer is C. The next question says, monochromatic light of wavelength 490 nanometers falls normally on a diffraction grating that has 6 times 10 to the 5 lines per meter. Which of the following is correct? So pause the video now, then unpause the video when you want to go through your answer. Right, so if you look at the equation for a diffraction grating, we know n lambda equals d sine theta. So therefore sine theta equals n lambda over d. So you can pop in all our numbers. Now remember, d is 1 over the number of lines per metre, so it's 1 over 6 times 10 to the 5. So therefore we work out sine theta to be 0.294 when we have our value of n to be 1. So therefore theta equals 17 when you work it through. So it tells you for the first order the angle is 17 degrees. So the answer is A. Let's now have a look at some questions for the mechanics and the materials topic. So a golf club strikes a stationary golf ball of mass 4.8 times 10 to the minus 2 kilograms, and the ball leaves the club with a speed of 95 meters per second. If the average force on the ball is 7,800 newtons, how long are the ball and the club in contact? So pause the video now, then unpause the video when you want to go through your answer. Right, so for this question, what you've got to do is use the equation that force is equal to the change in momentum over the time taken. Now, momentum is mass times by velocity, so therefore time taken is the change in momentum over the force. So we know that the mass is 4.8 times 10 to the minus 2. We know that the velocity is 95 and that the force is 7,800 newtons. So we get our answer to work through to be A. The next question says the velocity time graph for a fallen object is shown. So what shows the corresponding acceleration time graph? So pause the video now, then unpause the video when you want to go through your answers. Right, so how do you answer this particular question? Well, in this question, the gradient of the velocity time decreases with time because it's curving downwards. So this indicates that the rate of the change of velocity is decreased, which therefore indicates to us that the acceleration is decreasing. So our answer is going to be B. The next question says a body travels with speed v and which varies with time t is shown in the graph. One of the graphs shows how the distance s covered by the body varies with time t. So pause the video now, then unpause the video when you want to go through your answer. Right, so in this question the answer is going to be B, because the velocity increases in the first section, so that tells us that the rate in which the distance is being covered is increasing because there's a greater velocity every second. Now, but in the second section the velocity decreases, so the rate at which the distance is covered is decreasing. So whilst the distance being covered is still going up, it won't be increasing as much, so our answer is going to be B. The next question says, which row contains vector quantities only? So pause the video now, then unpause the video when you want to go through your answer. Right, acceleration, displacement, momentum and force are all vectors, whilst mass, energy, distance and speed are all scalars. That's rote learning you've got to have. So the only one that's correct is B. The next question says a uniform pitcher is suspended from a string which passes over a smooth nail. The tension in the string is T and the weight of the pitcher is 20 newtons. What is T? So pause the video now, then unpause the video when you want to go through your answers. Right, so how do you answer this question? Well, firstly, it tells you that the pitch is in equilibrium. So therefore, the forces up equal the forces down. So because there's two tensions acting upwards, we can say that 2 times by T vertical is equal to W. Now, we've got to resolve T into T vertical by doing T vertical is T sine 30. So therefore, 2 times by T sine 30 is equal to 20, the weight acting downwards. So therefore, T is equal to 10 over sine 30, which is 20 newtons, so our answer is going to be C. Right, the next question says a car bonnet represented by QP of mass 12 kilograms is pivoted at P. Its weight acts at G where QG equals GP equals 1 meter. What force F acting perpendicular to QP as shown is required to hold the bonnet at 30 degrees to the horizontal? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, again, as we know the object's in equilibrium, we know that the moments anti-clockwise equal the moments clockwise. So our moments clockwise, you can tell here, are going to be force times by the distance from the pivot point, which is 2, which then equals the moments clockwise, which is therefore going to be 12 times by 9.81, which is the weight, multiplied by 1, because there's a distance of 1 meter from the pivot, okay, times by cos 30, so we can work out what F is by doing 101.9 over 2, which is equal to 51 newtons. Now remember, we've multiplied it by cos 30 there because we're trying to work out that perpendicular distance. The answer is going to be B. The next question says a uniform rod is balanced horizontally about a support F. Forces of 400 newtons and 100 newton acts at either ends of the rod as shown. So what is the reaction force acting on the rod at support F? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is going to be D, 600, because again we want to take moments. Now it's an equilibrium, so we know the moments clockwise equals the moments anti-clockwise. Now we want to take the moments from the center because we don't know the weight of the rod, so if we put it at the center we won't need to consider the moment of the weight. So we can say moments clockwise equals moments anti-clockwise, so it's 100 newtons times by 2 meters, because we're going to take it from the center there. Okay, then we also know, okay, that moments anti-clockwise equals 400 times by 2 plus F times by 1, so we can say 200 equals 800 plus F. So at that point F is equal to 800 minus 200, so our answer is 600 newtons. The next question says a bird sits on a uniform rod suspended from vertical wires P and Q. So the rod has a weight W, okay, and is 15 centimeters long. The weight of the bird is 2W and acts at a distance x from P. What is the value of x when the tension in P is half the tension in Q? So pause the video now, then unpause the video when you want to go through your answers. Right, so our answer here is going to be C, because if we take moments from P, the moments clockwise equal the moments anti-clockwise because it's in equilibrium. So 2W times by x is equal plus W times 7.5, because again we've got to consider the weight of the actual object, equals Q times by 15. Now we know P plus Q equals 3W because the forces up equal the forces down. So as P is half the value of Q as stated in the question, therefore Q is going to equal 2W because there's 3W between P and Q, so therefore 2W times by x is equal to 30W minus 7.5W, so that tells us that x is equal to 22.5W over 2W, which is therefore equal to 11.3 centimeters. Let's have a look at some questions regarding electricity. So, a cylindrical conductor of length L, diameter D and resistivity ρ has a resistance R. What is the resistance of another cylindrical conductor of length L, diameter D over 2 and resistivity ρ? So pause the video now, then unpause the video when you want to go through your answers. Right, so the answer here is B, because we know resistance is equal to resistivity times by length over area. So half in the diameter will therefore quarter the area, because we know that the link between area and diameter. Therefore, it will increase the factor of resistance by 4, so our answer is going to be B. The next question says, which graph shows how the resistance per unit length R of a wire varies with diameter D of the wire? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer here is D, because as the area increases, the resistance will decrease in direct proportion. So this means that as the diameter increases, the resistance will also decrease in proportion. So as a result, we'll get a curved line of best fit because it's going to be linking to the square term in between area and diameter. So we'll get a curved line of best fit, so our answer is going to be D. The next question says a wire has a resistance of 8 ohms. A second wire has twice the cross-sectional area, twice the length and twice the resistivity. What is the resistance of the second wire? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that resistivity is equal to resistance times by area over length, so therefore we can work through that resistance is resistivity times by length over area, so therefore it's 2ρ times by 2L, because they've been doubled, divided by 2A, so therefore it's 4 over 2, so it's 2R, so it's double the original resistance, so it's 8 times by 2, which is 16 ohms. The next question says a metal wire has a length L and a cross-sectional area A. When a potential difference V is applied to the wire, there's a current I in the wire. What is the resistivity of the wire? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, resistivity is equal to resistance times by area over length. Now we know resistance is potential difference over current, so we can substitute this in and say that potential difference times by area divided by current times by length is resistivity. So therefore the answer will be B. The next question says, the diagram shows a 12-volt battery connected to a resistor of resistance R. The voltmeter reads 10 volts when the switch is closed. What is the internal resistance of the battery? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that in this question the lost volts is 2 volts because it's 12 minus 10 from the question. Now the potential difference is 10 volts, so that tells us that big R, which is linked to the potential difference, is 5 times bigger than small r, which is linked to the lost volts, because PD is 5 times bigger than lost volts. So the answer is therefore going to be B. The next question says, a student investigates how the potential difference V across the terminals of a cell varies with the current I in the cell. Which graph correctly shows how V varies with I? So pause the video now, then unpause the video when you want to go through the answer. Okay, so how would you answer this particular question? Well, the answer is going to be A, because when the terminal potential difference in a cell increases, we know that the current will decrease. That's because when a cell has an open circuit, it has a maximum potential difference but has a zero current, so therefore our answer is going to be A. The next question says, the diagram shows a network of resistors connected between terminals P and Q. The resistance of each resistor is shown. What is the effective resistance between P and Q? So pause the video now, then unpause the video when you want to go through your answer. Right, so how we can work it through is the answer is B, because you know that the total resistance will be the resistance in series plus the resistance in parallel. So what we can do is we can work out the parallel resistance by doing 1 over RT is equal to 1 over 4R plus 1 over 6R plus 1 over 3R. So when we work that through, that's 9 over 12R. Flip it over to get the total in parallel, which is going to be 12 over 9, which will give you 1.3R. And then as a result, we can then add that to the other particular value and we can work it through to get our answer of B. The next question says, a battery is connected to a 10 ohm resistor and a switch in series. A voltmeter is connected across the battery. When the switch is open, the voltmeter is 1.45 volts. When the switch is closed, the reading is 1.26 volts. What is the internal resistance of the battery? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you get your answer here? Well, the answer is going to be D, because lost volts is equal to EMF minus terminal PD. So lost volts is 1.45, the EMF, minus the terminal PD, 1.26 volts, which is 0.19 volts. Now the current is going to be the terminal PD over the load resistance, because that's the current in the circuit. So it's 1.26 over 10, so it's 0.126 amps. So internal resistance is going to be the lost volts divided by the current. So it's 0.19 over 0.126. The answer is 1.51 ohms. The answer is D. Let's now have a look at some questions on further mechanics. So, a helicopter circles continuously at a constant speed around a horizontal path of diameter 800 meters, taking 5 minutes to complete each orbit of the path. What are the speed v and the centripetal acceleration of the helicopter? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, the answer is C, as the angular velocity is 2 pi over t, so it's 2 pi over 5 times by 60 because we work in seconds, so we get 0.021 radians per second. Now the linear velocity is omega r, so you multiply that by the radius, which is 400 meters because the diameter is 800, so the linear velocity is 8.4 meters per second. Now the centripetal acceleration is omega squared r, so again it's 0.021 squared times by 400 because the diameter is 800, so we get our answer to be 0.18 meters per second squared, so the answer is C. The next question says, a ball of mass 0.30 kilograms is attached to a string and moves in a vertical circle of radius 0.60 meters at a constant speed of 5 meters per second. Which line A to D in the table gives the correct values of the maximum and minimum tension in the string? So pause the video now, then unpause the video when you want to go through your answer. Right, so to work out the maximum tension, we know the centripetal force and the weight must act in the same direction. So therefore it's mv squared over r plus mg. So you work that through to be 15 newtons. We then say the minimum tension is when the centripetal force and the weight act in opposite directions. So it's mv squared over r minus mg. So we get 9.557 newtons. So therefore our answer is going to be D. The next question says, a small mass is placed at point P on a horizontal disc which has a centre at O. The disc rotates anti-clockwise about a vertical axis through O with a constant angular speed. Which one of the following describes the force which keeps the mass at rest relative to the disc when the positions are shown? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this particular question? Well, the answer is D, because the centripetal force is being caused by the friction, and the centripetal force will always act towards the centre of the circle. So therefore our only possible answer will have to be D. The next question says, what is the angular speed of a car wheel of diameter 0.400 meters when the speed of the car is 108 kilometers per hour? So pause the video now, then unpause the video when you want to go through your answer. Right, so we know that angular velocity is linear velocity over radius. Now we know the linear velocity is going to be 108 times 10 to the 3 over 3,600, because they're going to turn from kilometers per hour into meters per second. So we convert kilometers to meters, and then from hours to seconds. Then we divide that then by the radius, which is 0.200, because the diameter is 0.400. So it works out to be 150 radians per second. The answer is B. The next question says, which graph shows how the velocity v of a body moving with simple harmonic motion varies with its displacement x? So let's pause the video now, and if you want to, when you want to go through the answer, unpause the video. So the question says that the condition of simple harmonic motion is where the displacement is directly proportional to the acceleration in the negative direction. So at its greatest displacement, this tells us that the velocity will have to be zero, because therefore you can work that through, because you've got the greatest acceleration when you're the furthest point away, so the velocity will have to therefore be zero. So at that point in no displacement, the velocity is a maximum, so therefore the answer would have to be B. Now the next question says, a model car moves in a circular path of radius 0.80 meters at an angular speed of pi over 2 radians per second. What is its displacement from point P 6 seconds after passing P? So pause the video now, then unpause the video when you want to go through your answer. So how would you answer this question? Well, if you look at the question, in 1 second the angular speed is the angular displacement is pi over 2 radians. So therefore in 6 seconds the angular displacement is 3 pi. But actually the displacement will be pi, because one rotation is 2 pi radians. So when it goes round once and then a bit again, the total displacement is actually going to be pi radians. So therefore the distance from the starting point is half a rotation, which is 1.6 meters. Our answer is C. The next question says, a particle of mass 5 times 10 to the minus 3 kilograms moving with simple harmonic motion of amplitude 0.50 meters takes 47 seconds to make 50 oscillations. What is the maximum kinetic energy of the particle? So pause the video now, then unpause the video when you want to go through your answer. Right, so how do you answer this question? Well, the answer is B, because the frequency is 50 over 47. It's how many oscillations you have in a second. So therefore it's 1.06 hertz. Our angular velocity is 2 pi f, so therefore it's 2 pi times by 1.06, so it's 6.68 radians per second. Now the maximum velocity is angular velocity times by amplitude, so it's 6.68 times by 0.15, so it's 1 meter per second. Now the kinetic energy maximum is going to be a half mv squared, so it's a half times by the mass, 5 times 10 to the minus 3, times by 1 squared, which gives us 0.0025 joules, which is 2.5 times 10 to the minus 3. Our answer is B. The next question says, the frequency of a body moving with simple harmonic motion is doubled. If the amplitude remains the same, which of the following is also doubled? So pause the video now, then unpause the video when you want to go through your answer. Right, so the answer for this question is C, because for a simple harmonic oscillator, the only term which has frequency in direct proportion to it is the maximum velocity. Vmax is equal to 2 pi f times by the amplitude. So therefore, when the frequency is doubled, the only factor which will also double is the maximum velocity. So therefore, our answer is C. So that brings an end to our revision session for today's lesson on AQA A-Level Physics Paper 1 multiple choice questions. So if you've been successful and you've learned in today's lesson, you should be able to answer A-Level Physics examination style questions, assess your own understanding on A-Level Physics, and understand what topics you need to improve upon for AQA A-Level Physics. So thank you very much for watching this revision session on Paper 1 multiple choice questions for AQA A-Level Physics. Thank you very much and have a lovely day.